Hello everyone and welcome to the latest episode of Pavement Matters, brought to you by Pavement Management Services. I'm your host, Lachlan McLean. Now, Pavement Matters is the show where we discuss all things related to pavement engineering, both past, present and future. Today, due to popular demand, we have Susan Tighe back. We were so happy with how she did last time that we said, you know what, come on back. She had plenty more to say. And today our topic is about sustainability in pavement. Now, sustainability is an issue that is discussed pretty much in every facet of everything known to man right now, but it is definitely important. And we're going to dive straight into it today. In case you didn't catch our last podcast, Susan was the past president of the Canadian Society for Civil Engineering. She's made waves in the field as a scholar, educator, researcher, professional engineer, and has also been a fellow of the Canadian Academy of Engineering. With over 30 years of experience, we welcome you again, Susan Tighe.
Well, that's great. Thank you. I am so delighted to be back in sunny Sydney, and it's getting cold in Canada, so very happy to be back here and chatting with you today.
Wonderful. Well, I think the most important question, and it may be very short, but I think it's probably got a lot to it, is why is sustainability so important?
Well, if we don't care about sustainability, our planet is going to die. So we obviously need to make sure that when we're designing things, we're maintaining infrastructure, we're even demolishing infrastructure, that we look for ways that we can recycle and reuse those materials. To me, sustainability is really a broad perspective, and it really encompasses everything we do. So, we don't want to be wasting materials. We want to be very careful about our environment. So, looking at things like low emission materials and thinking about, how we can reduce water usage when we're building and maintaining infrastructure, that we're not hauling materials long distances. So if we can, on our construction projects, that we can actually bring local materials ideally, as opposed to having to haul materials much farther distances. So sustainability can be defined in a very singular way, but the way I like to look at it is everything we're doing, and looking at how we can be more efficient and have less of an impact on our earth.
Okay, yeah, so it's really about every stage, from construction, the materials used, maintenance. Sustainability is something to be considered in every single level.
Yep, in all the stages of the project. So actually, from the time that we begin planning and programming, when we're even starting to think about what we want to do. So if we take an example where we're building a new road, from the point of planning and programming, we need to be thinking about what we plan to do. When we get into the design phase, the choices that we make. When we actually get into constructing it, the types of methods we use, the types of equipment, the materials, all of that we should be thinking that we're building in a sustainable way. As we maintain and do rehabilitation, when we're doing our in-service monitoring, when we're going out with our equipment and actually seeing how it's performing. And then, of course, end of service life. So instead of just demolishing, that infrastructure, of course, when we're decommissioning it, we want to look and measure the qualities of the concrete or the asphalt or the steel and think about how we can recycle it. Another important part of sustainability is doing life cycle costing. So we have tended in our industry to look at the low cost. So the lowest bidder gets the project and a low cost design. And what we do know is that often if we put a little more money up front into the infrastructure, we build it better, we use better materials, that we actually get a longer life. And if we get a longer life, that is by definition more sustainable too. So, and I think there's been a lot of really good work done. My research team has been involved in life cycle assessments. So again, these look at cost, but also emissions. They look at the opportunity to recycle. They look at different methods that we can use throughout the life cycle of the asset that are more sustainable and less harmful to the environment.
So you're clearly an early adopter and a thought leader for sustainability in pavements. You mentioned just then you've got a research team currently working flat out, I'm sure, to come up with a solution before we all die.
Yes.
Not to get too negative, it's just a joke, everyone. Just
yes.
that, it is a serious issue. But so what kind of things are changing? What kind of things are your team really pushing to try and get things to change for the better?
Well, we probably started this work in the early 2000s. So I started as a faculty member in 2000, and we probably had our first real projects in around 2004, 2005, where we were really digging into sustainability. And actually what prompted it was the Ministry of Transportation of Ontario at that time, or around that time, decided that they wanted to have the greenest roads in Canada. And we didn't know what that really meant, but I was doing a lot of research for the ministry at that time. And one of the early aspects that we really felt could be adopted and we could leverage was the recycled content in material. So at that time, we were recycling asphalt and we were doing testing, but we really weren't recycling concrete in the amount that we could be. And so I had a project early on where we were taking demolished concrete from different sources. So coming from bridges that were being demolished on the Trans-Canada Highway, pavement that was being demolished, and even Terminal 1 from Toronto Airport was being decommissioned and demolished. And so what we had proposed and our partners agreed to is that we were going to take that material, those different material sources, and test it like a new aggregate. So we had to make sure it was crushed properly. We used cone crushers at the time, which weren't all that common back then, but we used some cone crushers to really get the right dimensions for the aggregate, because what we were hypothesizing is that some of this material was equivalent to a premium aggregate, so the highest quality material. At the same time, in the province of Ontario, there were a lot more environmental rules coming in about opening new quarries and opening new pits. So we thought that instead of that material being directly put into a landfill, or it might be used for film material or in sort of not high quality applications. And so we went through this whole process and tested the materials, and it turned out that many of those materials coming out of this old infrastructure that for the most part had a very good successful service life, but it was being demolished because of capacity or other aspects. And so we were able to demonstrate that this material was indeed a premium material. And we were able to have agencies start to look at using this material for different applications and reusing it in the right spot. So if you had, let's say, this material that came out of an old bridge that was on the Trans-Canada Highway, and it was crushed properly and it was tested properly, and if it was a premium aggregate, it was going to be able to be used in a structural application. If it wasn't a premium aggregate, then maybe it would be used in a non-structural application or as fill. And so to me, that was a very instrumental project for my research group, because we did demonstrate that there were cost savings, there were environmental savings, because here we had this material that with some treatment would be successfully reused. So I think that was interesting. I think the other interesting projects that we worked on early were the use of warm mix, so warm asphalt. So, and particularly on hot days where you didn't necessarily want to use those materials at as high of temperature, and so you could actually use a warm mix. And also for end of season paving. So we were able to show that because it wasn't at as high a temperature coming out of the plant, the heat loss was less. And as the temperatures became cooler into the fall, you had more opportunity to get that compacted in place and really performing well because of the temperature differential between the environment and the construction materials. So lots of really interesting pieces of work that we were involved in early. And another really interesting one was Green Pave. So Green Pave was a program that was established by the government, the provincial government, the Ministry of Transportation. And we were looking at different things that contractors could do. So use local materials, use recycled materials, not use as much water during the production process, and actually help them establish a system that they could use to evaluate different projects. And that became very, very important because these projects then were deemed to be more sustainable and greener. And there was an incentive for the entire industry, so consultants, contractors, material suppliers, to think about the choices that they were making with respect to their materials and designs.
Okay. So that was a long time ago as well, wasn't it? Because we think of sustainability as this newfangled idea, but I mean, I suppose that my first experience with it, hopefully with a lot of other people as well, was Al Gore's film,
Right.
Inconvenient Truth, which would have been early 2000s, late 90s maybe. Does your work go back that far as well, or?
Yeah, so the climate change piece, we actually started doing work around 2007, 2008, and it was actually the first project in Canada where we started to look at the changing temperatures and how that should be impacting how we select the grade of asphalt cement. So, for example, using performance graded asphalt, your high temperature is the first number is the maximum temperature, and the second temperature is the 7-day minimum temperature. And so this system is really designed so that you can better select your materials for the application. And what we were starting to see is there were a lot of failures that were occurring. And the failures were happening early in the life cycle. And so what we decided to do is start to look at why we needed to have more flexibility in terms of the temperatures we were specifying. So that was part of some of the early work related to climate change. The second part really started to dig into flooding. So flooding in Canada is the most prevalent natural disaster. Now in other parts of the world, I mean here, for example, even this time of year, you're seeing forest fires. Now, we also see forest fires in Canada as well. But when we look at all the natural disasters, flooding is the largest one. And so what we were starting to see is myself, and I was working with a geography professor and an applied climatologist. And when I started the project, I didn't know what an applied climatologist was, but what I came to learn is these are professionals who study trends in climate. And what we saw really early on was that the amount of rainfall that was occurring was happening in a much shorter period of time. So let's say we got 50 millimeters or 100 millimeters of rain. Traditionally, you might see that over 4 days. And what we were seeing is we were seeing that same amount, let's say 100 millimeters over 1 day or 2 days. And so this was very problematic, of course, because we're seeing flooding of our infrastructure. And we needed to think about ways of actually draining the water quicker. So that really prompted a whole area of research on pervious concrete, porous asphalt, and permeable pavers. And so we embarked on these projects in Canada to look at how we could actually build, for example, pervious concrete that was able to withstand Canadian winter, but also be highly functional under these circumstances where we had a lot of rainfall. So the intensity was changing. And so we were able to do that, and we were able to look at designing some of this infrastructure that we could put it in places. So for example, on shoulders of roads or parking lots or places where we were able to design it to last and that the water drained through quickly.
Because that's one thing that about pavement is that it is hard. It's although porous pavements do exist, the majority of them are not.
Right.
It's basically this big long rock
Right.
that spans hundreds of kilometers, and especially in a place like where we are today, in a city, every square centimeter that is paved is something that used to be just
Natural.
earth.
Right.
And the rain would fall on the earth, it would sink down, it would do whatever water does once it gets to that point, it would return to the water table, but now it's got to go somewhere else. And that causes a lot of issues.
And also you have to think about those hot surfaces that are creating the heat island effect, right? So although this is not something that we have studied extensively in Canada because of our climate, but there are people who study cool pavement. And so what you're doing is looking at changing the color of the surface, trying to have it more porous. I am aware, apparently in Japan, although I haven't seen it, where they actually put water into the pavement and it evaporates during the day when it's extremely hot, and this helps lower the temperature in the cities. So, and obviously, I think one thing in Sydney that's good is, especially this area, there's a lot of trees and vegetation. And so again, if you're building infrastructure and you can actually use the rainfall, and I realize sometimes you go through drought periods, but if you use the rainfall as well to ensure you're watering your trees and landscaping, that actually again lowers the temperature.
Something I heard recently, that if you put money into a road on something like in something sustainable, say $10 million into the road, it might make the pavement more sustainable. It might have overflow effects for the rest of the community, but have you really made that road $10 million more valuable, as opposed to making a brand new road, consuming all this energy, all this raw materials? With that, you've got a brand new road worth $10 million. So sustainability really needs to be put first, and a major paradigm shift, I think, is needed. Even today, when everyone is aware, and it's not possible to not be aware anymore, we still need to push this through.
Well, and if I may add that, so there's different ways to value assets, right? So there's the pure financial way, but another thing that we really need to think about in this industry is our wildlife and our habitat that lives around our roads and around our communities. And so one of the things that has really been, we've been focusing in on is, if you have turtles that need to cross the road because of their mating season, and we need to make sure that we don't have vehicles driving down those roads at these top speeds. If we have sensitive areas, we need to be protecting the wildlife, and certainly, watching some of the forest fires in Australia. and seeing some of the koalas and the wallabies and kangaroos and sort of their whole environment is destroyed. And so how do we protect those? I mean, the echidnas and wombats, and I know there's a lot of other animals here, but I think that we need to be aware of that. And so, and we do need to be thinking about where we put these roads or airports, airports as well. Airports can obviously super important part of the transportation infrastructure, but we also know that they can be highly detrimental for bird colonies, and both for passengers on planes, and they can be just difficult, but also just destroying some bird colonies. So we have to think about these things, and this is where as well we have to work with people who are skilled in these areas that understand where the animals are, and how are we making sure that we're not destroying those areas that they need to live, because if they don't have the habitat, they're not going to be able to live.
So right now the hot topic, a lot of people are calling it the fourth industrial revolution. I'm not sure what the other three are, but that's what it's being called. AI and machine learning. There has to be some sort of way to implement this from a sustainability perspective as well. Are you aware of any potential solutions?
So let's talk first about AI applications for the way we do our work in sort of the pavement area, and then we can talk, I think, more broadly. So I have for some time been using machine learning, looking at how we actually assess distresses, and so taking automated, whether it be cameras or from equipment that we use, high-speed equipment, and actually assessing those pictures and using machine learning and different tools to figure out, oh, you've got this many cracks, and your road is performing at this level and that level. So I think, and that's artificial intelligence. I mean, so I think that there's many applications that can help us better manage our infrastructure. From a sustainability perspective, again, if we can use some of these technologies to somehow change our behaviors so that we're not having as big of impact on the environment, or creating more pressure that actually results in more climate change. So pollution, we know, we also know that during the pandemic that there were a lot of natural animal populations that really improved because we weren't flying airplanes the way that we have traditionally, or using trucks to the same capacity. And there's no question traffic was way down because everybody was at home, and air quality was notably different. You saw cities in the world that traditionally are totally smog, and we saw during COVID that we didn't have that. So how does this relate to AI? Well, I think that we can use some of these tools to help us to better manage our world and better understand our world, and then ultimately have less of an impact on our world. So I think that's our challenge. Like, how do we always, when a new technology is introduced, how do we use it for good? And I think that is the onus on us. And I think to be curious and creative in what we're doing, and then see how we can actually use this to be a positive force and not a negative force.
I suppose the advantage we have here is that we really have a bit of a clean slate here. It's nothing really in history since, maybe even in the future, has ever been anything like this. It's, artificial intelligence has been science fiction for hundreds of years, and now it's finally here. We have the opportunity to shape it into exactly what we want, and well, we can only hope that people are smart enough to use it in the right way.
Yeah, and I think that's where we need to be knowledgeable owners and knowledgeable users, right? We can't, whatever we're doing, we always have to have a holistic approach. And so, I guess going back to the first podcast, the thing that I like about being an engineer is looking at the systems approach and trying to look at, an issue or problem from different angles. And I think as long as we continue to do that and strive to see what the advantages and disadvantages are, that's important. I mean, any technology in history, if you look back, often there's a downside. And so then how do we manage that downside? I mean, I think the thing for me, being an educator at heart, it's great that we have this tool. And I think you said it earlier offline, is that, we can't just rely on that, and we can't use that to do all the thinking. Nothing replaces a person actually thinking through an issue or talking to another person about it. And so the accuracy of some of the information that comes through is questionable. So we have to be able to say, okay, this is correct, or we agree with this, and maybe this piece isn't. And then, then we don't necessarily implement that. I think that's the tricky piece. How do we know when something is accurate, and how do we know when something's not accurate? There's obvious things that we can tell, but I think if we're going to use this for complex problems, we're going to also need to make sure that we have the time to really look at it and make sure it makes sense.
Of course. One of the things I was told growing up, which I find quite funny, is that you'll never be able to replicate creativity, which I think is almost not true anymore, because we're seeing these artificial language models almost replicating creativity. So what's next? What can they not replicate? And I believe it's critical thinking, being critical of ourselves, I suppose, which is always relevant for sustainability, and also being critical of whatever AI is the going one at the moment.
Well, and I think the other thing that they cannot replicate is human emotion. So like the interactions that you have, and empathy or compassion or love or anger, and I actually think all of those emotions are extremely important to how we think. And so if we look at it, you have the textbook answer and you have the real world answer. And so my sense, and who knows, maybe we can revisit this some other time, I don't know, but I think the textbook answer is not always the right answer. And so if we think about AI, and we think about, the creativity piece, if you define creativity by creating new knowledge, maybe it isn't new knowledge, because AI is basically taking vast amounts of information and bringing it together, where a human would take those emotions and all that background and bring it together.
Of course. Well, I believe that's all we've got time for today, but thank you once again for coming down, Susan. It's always a pleasure. And everyone who's listening, thank you very, very much for joining us. As always, you can leave a comment down below, and you can subscribe to us on Spotify and Apple Podcasts. I hope to see you again on Pavement Matters soon. I'm Lachlan. This is Susan.
Thank you.
And we'll see you next time.
Bye-bye.
Bye.